Hello guys, welcome back to Tech-Bimba channel. So far I have been covering videos in our North Karnataka language as a part of this playlist, right? Starting from Java programming language introduction to I have covered topics till collection framework. Recently I got a suggestion from my friend I should start creating a videos in English too so that it can reach to a wider audience. Having said that, now onwards I'll be creating videos in both the languages, right? So today I have started with a threads concept. I already uploaded a video on a multitasking in our Kannada language. So as a part of this video I'm covering the same topic in English too. So without wasting any time, let's get started. Before jumping into what is thread, what is multi-threading, it's very important to understand few of the basic concepts. So in this diagram we can see that in this computer there are plenty of applications installed and many of them are actually running. So what these applications are meant to do? So let's say Skype. Skype is meant to basically chat within the organization and do a video call. What YouTube offers us? YouTube is a video platform. Here content creators can come and they can upload the videos and consumers can basically consume that. Then Gmail offers a mailing services. So each application is meant to solve particular business problem, right? So what this application actually contains so that they will be able to perform these actions, right? This application is nothing but packages of the programming files. Say suppose I got a requirement to develop a Swiggy in Java, right? What I will do? I will do first requirement gathering, then I divide the components to subcomponents, then based on the requirement I will start coding. Since I am developing a Java application, I will be writing the programming files as .java files. Once I am done with all the coding, I will do the testing, then I compile those classes whatever I have developed, then I will package them as a .war file or a .jar file. Those .war file and .jar file is deployed into a server like a Tomcat server. This is how actually we create the application. So if you basically deploy the .war file, then we extracted that war file, right? You can see that it contains plenty of a .class file. These .class files are nothing but executable files of our programming files that initially we created. So hope this is clear, right? What is application and what actually application underneath contains. So now say suppose in your computer you have downloaded a skype.exe, then you installed it. Once you installed it, what it will happen here is, so from this executable installer basically extract the programming files and it will make one folder, and within that folder all the executables of the files will be present. So till that point it don't have any relevance. Now when we want to basically use this Skype, what we will do is we'll double click on this Skype, then process of the Skype is created. This Skype instance starts executed. So operating system allocates the required resources, like how much memory is required to execute this process, how much stack is required, how much register is required. All those resources are allocated to this process by operating system. This application, Skype application, is nothing but it's a package of the programming files, right? Those programming files will be like in a case of Java, it will be in a bytecode format like a .class file, right? So it figures out what is the starting point of that programming file. Once it figures out that, it invokes that, and from then onwards instructions present in that dot class file will be start executing. This is how the actually application works. So with this we can say that process is an active instance of the application, right? Since application is nothing but a package of the programs, right? That is the reason we also call process is an instance of the program. Okay, let me demonstrate this statement with an example to you guys. Here I have created a one application. So for a demo purpose I have just created a one class my app. So this is a Java file, so I saved it as a myapp.java. Within this Java file, right, I have created a method public static void main. Then I have written a statement system.out.println hello world. I want to print this statement in a console. Then there is a statement like a thread.sleep. So don't worry about this one. So we'll be covering what is thread.sleep in our future videos. So what it does is basically it makes this program to abort and it will go for a sleep for a 30 minutes. Once the 30 minutes are elapsed, then control comes to this line and it executes. Now I have opened two terminals. So inside a JDK, right, there is a tool called JPS. So what this JPS does is it will list down what all the Java virtual machine processor actually currently running. So if you type JPS now, it's only showing JPS itself. So this is a process ID. This 19212 is the process ID of the JPS. So now what I will do is I will compile my .java file. So compilation is done. Now if you see here, myapp.class class is generated. This myapp.class is nothing but a bytecode. Now if I do java myapp, so with this command what I'm doing is I'm executing bytecode, right? Now if I hit enter, what is happening here is, so within this .java I have a system.out.println hello world. So hello world got printed here. Since I have a thread.sleep, so now this program is in a abort state, so in a sleep state. So it waits for 30 minutes, then this is going to print this line. Now in a second console, if I run this JPS again, now we can see that our my app is running as a process. So here we can see process ID as 11648. What happens here is basically here we are running our program, but here if you see one process got created. So this process is a Java virtual machine instance, right? That's the reason we even got a process ID also. Because of this, we can also call process is nothing but an instance of the program. Now let's see what happened. What is actually happening when we run Java my app. Once we invoke this one, we are providing a class name to the JVM and we are asking JVM to run this. Then JVM process starts. So JVM instance is gets created. So this JVM instance will be having a different memory areas like a code segment, data segment, stack, register. All those will be there for this JVM instance. Then class loading will happen. So we are having a myapp.class, right? This class will be loaded into the memory. Then resources will be allocated to this process. Okay. Then JVM figures out what is the starting point of the program. So in our case, it's a main method, right? So JVM figures out main is the starting point of the program. So it invokes that, and then within this main, what all the instructions we have provided, those will get start executed. So this is how actually process runs, and we call process is an instance of the program. What is JPS? JPS is a tool provided by the JDK to check what all the active process running, what is the active Java virtual machine processor currently running on. So in case we need a more info on this process, we have -L. If you execute the JPS with -L, right, it will basically print out the package. So if you see here, it is saying JPS is present in this package. Okay. Now I have said that once we basically execute any of the application, process will be created, and for that process OS is going to allocate the resources. In this case, say suppose I have basically double clicked on the Gmail and also I am working on a Skype. Then here process 1 and process 2 are created, and OS allocated a resource for process 1 and also it allocated a resource for process 2. But these resources are specific to this process, so these are not shared among the processes, right? Those don't interfere. This is very important point. Now next question is, what is actually multitasking? Multitasking is the capability of the CPU to execute more than one task at the same time. In a simple terms, we are able to execute Gmail also, YouTube also, and I am able to chat using a Skype also. So I am able to perform more than one action, right? Even in a mobile, we can basically use more than one application at the same time. This is what is called as a multitasking. But how actually this multitasking is going to work? So here, let's say we are having a CPU with only one core, and we are having a different applications like Gmail, word processor, web browser. So all those processes are in an active state, right? So user is using a web browser also, Gmail also, and word processor also. So for all those application instances, processes are created. So since we are having a single CPU and single core, this is a CPU or a single core is like a brain of the computer. This is the one going to execute these processes. Since here we are having only one CPU and one core, at a time it can only execute one process. So how actually it works is, here context switching will comes into a picture. So all those processes will wait in a queue. So if you see here, process 1, process 2, process 3 are waiting in a queue. Operating system basically uses the scheduling algorithm. There are many scheduling algorithms. One of them is like a round robin. So what operating system does is, so it picks the process 1 and it gives the process 1 to CPU. CPU executes this process 1 for X minutes or X seconds. Say suppose CPU executes the process 1 for a 10 seconds. Still process 1 is not completed, but allocated time for this process 1 is elapsed. Then operating system again place the process 1 back to the queue. Then process 2 gets its turn. CPU executes the process 2 for next 10 seconds. Once the time elapsed, again operating system puts the process 2 back into the queue. Then process 3 gets its turn. So CPU executes this process also for 10 seconds. So once the 10 seconds are elapsed, again operating system is going to put the process 3 back into the queue. So again, since the process 1 is still not completed, right, again CPU is going to pick the process 1. That is the reason we call it as a round robin algorithm. So within a circle, all the process will get the CPU time and execute that process for that particular allocated time. Once the allocation time is done, again process will move to queue state. Those will be moved to queue, right? So this is called as a context switching. So all this will happen so fast that for us it appears like CPU is executing more than one task at a time. But If you see at the nanosecond level, right, CPU is executing only one process at that time. Since it's going to execute so fast, it appears like CPU is executing more than one process at the same time. Say suppose our computer have a more than one cores. In this example, we can see that our computer have a CPU core 1 and CPU core 2, and we are running a Notepad++ and a Gmail. For a Notepad++, one process got created, and for a Gmail, one process got created. Operating system assigns Notepad++ to CPU core 1 and Gmail process to CPU core 2. Since both the cores have the capability to execute the assigned process simultaneously, here actually they execute the assigned process. Here actually multitasking happens. Key thing to note here is number of a processor equal to number of the cores present in the CPU. That is the reason here actually multitasking happens. But what happens if the number of the processor more than number of the CPU cores? Then again context switching will comes into picture. Using that context switching only, CPU will be able to execute the processes. So this is how basically CPU executes more than one task at the same time. Underneath, it's executing only one process, but it happens so fast that it appears like it's executing more than one task at the same time. So as a part of this video, we have seen what is application is, what is process, then what is multitasking, what is context switching, how basically CPU uses the context switching to execute more than one task at the same time. So in a next video, I'll be talking about what is multi-threading. If you guys found this video helpful, don't forget to share, like and subscribe to this channel for such a more content. Thanks for watching this video. See you in the next video. Thank you.